Hello and welcome to my online learning course. My name is Mr. Hattenbrah, and today I'll be teaching you about the direct comparison test. There comes a time in every mathematician's career when you have an infinite limit and infinite series that it's just too complicated to figure out whether it converges or diverges. So with the direct comparison test, you can easily figure out whether it converges or diverges. Let's say you have an infinite limit, a to the n, and you can compare it to the infinite series b to the n. Sorry about my penmanship. I'm not quite used to this program yet. Now, one thing must be assumed is that a to the n is less than or equal to b sub n, and they're all greater than 0. Things that are given is if b sub n converges, then a sub n also converges. That is a given. Something else. If, let's say, the smaller one, a sub n, if that converges, if that diverges, then b sub n will also diverge. That is given. Now, whoa, now that is crazy. On to an example. Let's say we have the infinite series 2 to the n plus n. Now, not too complicated. So let's write out the first couple terms. When n equals 1, 1/3. N equals 2, 1/6. N equals 3, 1/11. And 1 equals 4. N equals 4, 1/20. And so on. Now, we can see obviously here that 2 to the n will grow much faster than this n term. So we can compare it to simply, this is where the direct comparison comes in, 2 to the n. Now let's write the first couple terms of that. N equals 1, so 1/2. And n equals 2, 1/4, 1/8, 1/16, and so on. Now, using this, it's much easier to find the convergence or divergence of than this is. So, oh no, how does this work? Now, using the geometric series test for 1/2n, we know that the absolute value of 1/2 is less than 1 and greater than 0. Therefore, those. The three little dots mean therefore, by the way. Therefore, the series 1 over 2 to the n converges. Now, since this larger series, we'll call 1 over 2 to the n the larger series, because just from looking at these, you can tell this will be larger. So since the larger series, 1 over 2 to the n, converges, the smaller series, 1 over 2 to the n minus n, plus n, must also converge, as given as stipulation number 1. Thank you for listening. Namaste.